Hello and welcome to the course Environmental Monitoring and Instrumentation. This course is a part of e-learning initiative of UGC for the development of MOOCs in environmental studies for SWAYAM portal. I am Dr. Arpana Agrawal, the course coordinator, working as an assistant professor at Department of Physics, Prime Minister College of Excellence, Shri Neelkanteshwar Government Postgraduate College, Khandwa, Madhya Pradesh. This is the course overview. The course is designed to provide a comprehensive overview of environmental monitoring methods and instrumentation. The course provides an in-depth knowledge of advanced analytical and spectroscopic techniques employed for environmental monitoring. It includes the principles, instrumentation, and methodologies, along with practical applications of separation, spectroscopic, microbial, molecular, and bioanalytical techniques. These are the learning objectives of the course. By the end of the course, the students will be able to explain the need for environmental monitoring and describe the various types of environmental pollutants. They can apply appropriate sampling techniques and follow good laboratory practices. They can describe the working principle, instrumentation, and application of chromatographic and spectroscopic techniques. They can analyze environmental samples using techniques like GLC, HPLC, AAS, UVVs, and FTIR. They can demonstrate the understanding of microbial and molecular biology techniques such as PCR, DNA sequencing, and microscopy. They can utilize bioanalytical tools including biosensors and microarrays in environmental diagnostics. They can operate basic field instruments for air, water, and soil quality monitoring. They can also interpret environmental data and contribute to environmental impact assessments and pollution management strategies. This is the course structure. The course is organized in 4 structured phases comprising a total of 40 modules delivered as 25-minute video lectures over 15 weeks. The estimated workload is 25 minutes video lecture scheduled for 3 days in a week, along with assignments, quizzes, and interactive sessions scheduled for the rest of the days in a week. The last week of the course is scheduled for examinations. This is the first phase of the course, and in the first phase, we will focus on basic concepts of environmental monitoring, highlighting the significance of sampling strategies like graph, composite, and continuous sampling. It also emphasizes good laboratory practices and quality assurance for reliable data collection and analysis. In the phase 2, learners will explore key analytical techniques such as chromatography, including GLC, HPLC, SFC, used for separating and identifying pollutants. Also, the spectroscopic methods like UV visible spectroscopy, atomic absorption spectroscopy, Raman spectroscopy, and FTIR are discussed for detecting the environmental contaminants. The third phase will focus on microbial and molecular methods, including the use of various microscopes and techniques like electrophoresis and PCR. DNA sequencing methods and their applications in environmental diagnostics are also covered. In the phase 4, bioanalytical tools and field instrumentation such as biosensors, remote sensing techniques, and IoT-based monitoring systems will be explored. It also includes practical case studies related to environmental impact assessments and disaster site monitoring. Finally, we have a test series scheduled during the last week, and in addition to that, we are also having assessments based on assignments and online quizzes every week. We are also holding some special sessions of interactive discussion on different modules in each week. The course assumes a foundation understanding of environmental science and basic chemistry. Therefore, it is best suited for final year undergraduate students and postgraduate students in environmental science, chemistry, biotechnology, and relevant fields. This course carries 4 credits and mapped with National Credit Framework Level 7, which corresponds to postgraduate and advanced diploma level learning outcomes. The course evaluation will consist of 30% internal assessment and 70% end-term proctored examination conducted by NTA. The the internal evaluation comprises 42 assignments, including 2 graded assignments and 40 self-paced non-graded module-wise quizzes. The graded ones will schedule after second and fourth phase and each carry 15%. This will involve a mix of short questions, analytical tasks, and problem solving. The evaluation will be based on timely submission, clarity, application, and real-world relevance. The end-term exam will be conducted by NTA, and the paper design ensures 30% easy, 40% moderate, and 30% difficult level questions. It includes MCQs, analytical and case-based questions, diagram-based instrumentation items. The exam assesses understanding, application of methods, and integration of lab and field-based approaches. This course has strong relevance to industry sector such as environmental consulting, waste and wastewater management, safety and pollution control boards, pharmaceutical and agrochemical industries, research and development labs in environmental, diagnostics and sustainability. It is also well aligned with the National Education Policy 2020 and focuses on interdisciplinary, industry relevant, and skill based learning. So, thank you very much for choosing this course, and let's work together to develop a sustainable environmental solutions using the power of science and modern instrumentation. I wish you a great learning experience ahead. Thank you.